Good morning, everybody. I hope you had a good long weekend and you're ready for a short week this week. Today we are going to do some review of special right triangles and trig before we start our next unit. So, um, what you guys have attached to your assignment is this sheet right here that just says special right triangles and trig review. So what I want you guys to do is make sure that you have that pulled up and you are looking at that while we're going through these examples. So we're going to do all of these together today. And so you guys won't have any assigned homework, but I am going to attach practice with all of this stuff in case you guys want to work on it a little bit more, because some of us haven't seen it in a while. So the first thing that we are going to do is we are going to simplify the following radicals. So remember, when we're simplifying radicals, we're thinking of our square roots. So thinking of our perfect squares, that's our 1, 4, 9, 16, 25, 36. So what we're going to want to do is we are going to want to, if I'm taking a look at simplifying the square root of 20 here, I want to see which one of these perfect squares is a factor of 20. Well, when I go down this list, the first one that's a factor of 20 is going to be 4. So I want to break 4 up into 4 times 5. And then what I can do is I can split apart my 2 into 2 square roots. So I can make this the square root of 4 times the square root of 5. Then I can simplify that square root of 4. So now I have 2 and then times the square root of 5. And now I just want to double check. I can't simplify the square root of 5 any farther, so I'm done with my first one. Then I'm going to repeat the process here for the next two. So the square root of 18. The first one that 18 is divisible by is 9. So 18 is 9 times 2. I can break this up into each one of my square roots. The square root of 9 is 3. And I'm left with 3 square root 2. The last one is 32. As I kind of go through here, first one that 32 is divisible by, when I'm going from the bottom up, is 16. So I can split this up into 16 times 2, or the square root of 16 times the square root of 2. The square root of 16 is 4, so 4 square root 2. So really, when we're simplifying radicals, we just want to find that greatest factor that is a perfect square, break it up, and take the square root of that perfect square. So the next thing we want to do is find the missing side using the Pythagorean theorem. So if you guys remember what we've done in class before, and I don't know why I have a little 45 here, we're going to make this go away. Pythagorean theorem, we have a leg squared plus a leg squared equals our hypotenuse squared. So if I'm going to do number 11 first here, I'm going to remember that my hypotenuse is whatever is opposite of my 90-degree angle. So that means one of my legs is going to be 6 squared, plus my other leg here is y. So I have y squared equals my hypotenuse squared, which is going to be 10 squared. So when I simplify this, 6 squared is 36, plus y squared equals 100. And if I subtract over my 36, I get y squared equals 64. And if I take the square root of both sides, I get that y equals 8. And that is my missing side. Okay, now if I look at number 10, this one's a little bit different because what I have to notice is that I have these two congruency marks on my two legs. So if I'm given two congruency marks and one of them is labeled 6, that means I can know that my other one is also a 6. So now I could do leg squared plus leg squared equals hypotenuse squared, or 6 squared plus 6 squared equals x squared. Well, 6 squared is 36 plus 6 squared is 36 equals x squared. 36 plus 36 is 72 equals x squared. And if I take the square root of both sides, I see that x equals the square root of 72. Well, now I want to simplify this radical. Since I know how to do that, I can break 72 up into 36 times 2, which simplifies. The square root of 36 is 6. 2 can't be simplified any further, so 6 root 2. So this one is actually really nice because hopefully what you guys noticed on this one is that if I have a right triangle that is isosceles, that is going to be my 45, 45, 90 triangle. So what I can do is I could draw a right triangle, and if I have my other two angles being 45 degrees, I know that my legs are going to be congruent. So if I label my two legs X, think about for a second, what did we say that our hypotenuse would be? My leg was X, what would my hypotenuse be? And if I look up at number 10, kind of as a guidance, I had legs of 6 and I had a hypotenuse of 6 root 2. Well, the same thing's going to work here in any 45, 45, 90 triangle. If I have legs of X, my hypotenuse is going to be X root 2. So what is this going to look like in general? And actually, let's take a look at this a little bit more because we talked about a little bit more in class. So if I wanted to go from one of my legs back to my hypotenuse, I can just think about multiplying by the square root of 2. And if I want to go from my hypotenuse back to one of my legs, I can think about dividing by the square root of 2. So here, if I want to try that with 12 and 13, let's try it with number 13 first. I'm given a right triangle with two congruent sides, which means I know that this is a 45, 45, 90 triangle. So that I know I have an x, x, and an x root 2. So if I'm wanting to go from my hypotenuse to one of my legs, that's when I'm going to divide by the square root of 2. So if I do 5 square root 2 divided by the square root of 2, my square roots cancel out and I'm just left with 5. So I know that my leg here is 5, and if they're congruent, my other leg here is also going to be 5. And I'm done. Number 12, I have a very similar triangle. I'm given a right triangle with two congruent legs. So I know that my angles are 45. Again, I'm given a hypotenuse, so I'm wanting to go from my hypotenuse to my leg, which is dividing by the square root of 2. So if I do my hypotenuse, which is 12, divided by the square root of 2, this is going to give me my legs. But I can't just leave my I can't just leave my answer as 12 divided by root 2. I have to rationalize the denominator. This is something we might not have done for a little bit. So remember, when we rationalize the denominator, I'm going to multiply both the top and the bottom by my radical. So if I do 12 times root 2, I get 12 root 2. If I do root 2 times root 2, I get the square root of 4. When I simplify, I get 12 root 2 over 2, or 6 root 2. So that tells me that both of my sides are going to be 6 root 2. All right, the next one that I want to look at is my 30, 60, 90 triangles. So in order to look at this one, I first want to start with an equilateral triangle. So 60, 60, 60. If it's equilateral, all of my side lengths are going to be the same. So let's say each side length is 2. So how would I create a 30, 60, 90 triangle? I could take this equilateral triangle and I could split it in half using my height or my altitude here. And if I split it in half and use that perpendicular bisector, then I know my base is going to be split up into 1 and 1. My hypotenuse, or the hypotenuse of both triangles, is still going to be 2 because I didn't change anything. My top angle here that I split is bisected, so I get 30-degree angles on both sides. So now I created two 30, 60, 90 triangles. So what I want to figure out is what is that height that I created. So just as a quick reminder, we could find that by doing the Pythagorean theorem. So I could, if I called the height h, I would say h squared plus my base of 1 squared equals a hypotenuse 2 squared. So h squared plus 1 equals 4. Subtract my 1 over and I get h squared equals 3, or h equals the square root of 3. So my height equals the square root of 3. So when I'm thinking about this, kind of in terms that we've talked about it before, if I have a 30, 60, 90 triangle, remember that we talked about this as being, we have a short leg, a long leg, our hypotenuse. Well, if my short leg is 1, so my bottom one is 1, my hypotenuse is going to be 2, and my height, or my long leg, is going to be root 3. So my legs are in a ratio of 1, 2, and root 3. So let's use that ratio to solve these two triangles. So in this first one here on the left, I'm given that I know my 30-degree angle. So let's take a look. The 30-degree angle is opposite of my short side. So that means 7 is my short side. My hypotenuse is opposite of my 90 degrees. And what's left over is going to be my long side. Oops. So if my short side, if I'm looking at my 1 root 3, 2, my short side is 7. My long side is going to be 7 root 3. My hypotenuse is going to be 14. So short side is 7. Long side is 7 root 3. My hypotenuse is 14. All right, on this next one, I'm given my hypotenuse is 10. So again, if I'm doing short, long, hypotenuse, I'm given my hypotenuse is 10. And I'm thinking 1 root 3, 2. Okay, if my hypotenuse is 10, then I know that my short side is going to be half of that. So we're going to have a 5. And if I have a short side of 5, I just multiply by root 3 to get my long side. So I get 5 root 3. Oops. All right, the last one, or the last part of this, we're going to look at our trig functions. So I'm not going to do all of these because that would be very, very time consuming, and I'm going to do a couple of them, and then I'm going to post the answer key for the rest of them so that you guys can practice if you want. So we're going to find some of the missing sides and angles. And what we want to remember here is this SOHCAHTOA. So remember, if I write it up and down, I have SOHCAHTOA. So I have my sine is opposite over hypotenuse. My cosine is adjacent over hypotenuse. And my tangent is opposite over adjacent. So in this very first one here, we are given the angle A is 32, and we want to find X and Y. Well, if A is 32, and I have a 90-degree triangle, I could figure out angle B by doing 180 minus 90 minus 32, and I would find that B is 58. And then I can use my trig functions to find X and Y. So if I want to look at angle A and I want to find X, I'm thinking X is my opposite, and so my hypotenuse is going to be side AB, and my adjacent is going to be my 13. So if I'm trying to solve for X, I need to use my opposite and my adjacent. So that's going to be my tangent. So the tangent of 32 equals opposite over adjacent. Then I want to use my cross products and say that X equals 13 times the tangent of 32. And if I type that into my calculator, I would get that X is approximately 8.1. And then when I solve for Y, I could do it one of two ways. Since I know that X is 8.1, I could use my Pythagorean theorem to solve for Y. Or I can look and I could see that Y is my hypotenuse. So instead, I could use the adjacent and the hypotenuse to solve for Y. So I could use my cosine of 32 degrees equals adjacent over hypotenuse and do my cross products. So I would get that 13 equals y times the cosine of 32. Divide both sides by the cosine of 32. And I would find that y is approximately 15.3. So both ways should get you about the same answer. So it really doesn't matter which way that you do it. Both ways will work. All right, let's take a look down here. I want to move down to number 16. Number 16, we're given two sides, but we are not given an angle. So if I'm solving for an angle, remember that I have to use my inverse trig functions. So let's label my sides. Right here, this is going to be my hypotenuse, my AB. If I'm looking for my opposite and adjacent, I'm going to be looking at that theta. So opposite of my theta is going to be side AC. My adjacent is going to be side BC. So if I'm solving, I need my adjacent and my hypotenuse. So if I'm gonna rewrite on top my SOHCAHTOA so I can see it a little bit easier. So adjacent and hypotenuse, that's going to be my cosine. So I'm going to be looking at my cosine function, but since I'm solving for an angle, I need my inverse cosine. So the inverse cosine of the adjacent over my hypotenuse is going to equal my angle. So when I type in the inverse cosine of 4.4 over 11, I get that theta is approximately 66.4 degrees. And now I can do 180 minus 90 minus 66.4 to get that angle A is 23.6. And then I could either use trig or the Pythagorean theorem to find that opposite side. I'm going to do one more with the inverse trig, just because I feel like this is one of the more tricky ideas. So, angle B is my theta. I'm given CB and I'm given AC. So, opposite of my theta is AC. My hypotenuse is AB. So that means CB is my adjacent. So it looks like I am given my opposite and my adjacent. So opposite over adjacent is tangent. So I'm wanting the inverse tangent since I'm solving for an angle of opposite over adjacent. That's going to equal my theta. So the inverse tangent of 7.7 over 14 equals theta. So theta is approximately 28.8 degrees. And again, I can use Pythagorean theorem, and I could do 180 minus 90 minus 28.8 to solve for the other two missing pieces. Alright guys, so I am going to have some extra practice on the Google Classroom along with the full answer key from this worksheet, so you guys could check answers. You guys can practice a little bit more specifically on what you guys feel like you need more practice with, but please feel free to email me if you guys have questions.